So in this section, we are going to talk about non-Newtonian fluids. So as we look at it, we've had this Newton's law of viscosity that we've talked about. The shear stress is the viscosity times how that velocity changes with respect to the height. Any fluid that obeys this relationship, we call a Newtonian fluid. So Newtonian fluids make up the bulk of what we're going to be dealing with. So most common fluids are going to be Newtonian. Water, gas, oil, these are all, will all obey this relationship. They are all Newtonian fluids. So there are other fluids that do not obey this relationship, where their viscosity varies with the applied strain. And so these are given the really surprising name of non-Newtonian fluids. I forgot a W there. Newtonian fluids. And so these are anything that do not obey Newton's law. Excuse me. So we have three types of non-Newtonian fluids. The first one is what we call a dilettante. So dilettante fluid is a shear thickening fluid. So that means as I apply shear, that the viscosity changes. I put thickness, that should be shear thickening. So shear thickening fluid. Cornstarch and water. If you do any cooking, put some cornstarch in water, you beat it with a fork, it gets thicker. That's what you use to thicken your sauces. Another one, you guys could actually give this a try when you go out to the beach or whatnot, sand and water. Sand and water together, if you start beating it together, it becomes harder and thicker. In fact, that's what quicksand is. Quicksand is a sand and water mixture, and that's why when you get caught in quicksand, what are you supposed to do? You're supposed to relax and float. What happens is people struggle in it, it gets thicker and harder, that's what drags you down and drowns you. So if you take nothing else from this class, you at least know how to survive out of quicksand. Second type, the opposite of the dilettante, is what we call pseudoplastic. Pseudoplastic. Pseudoplastics are what are called shear thinning fluids. So shear thinning. You apply force to it, it thins down. Blood plasma. It's not really one you can try yourself, but you can go in the cafeteria. Syrup and molasses are both ones that if you beat them with a fork, they will start to flow a lot better. Much the same way that you can heat up syrup to make it flow better, well, you can also add that shear force to it. The last one is actually probably my favorite out of the non-Newtonian fluids, and that's a Bingham plastic. Bingham plastic fluids are very interesting because basically they require a shear force of flow. So it requires shear to flow. Toothpaste is a Bingham plastic. Ketchup is the best example because it is the tastiest. So I've got a couple of videos here. Two of them I'm going to have separate because there's sound required. But the first one is, this is cornstarch and water in a speaker cone. And it's kind of neat because you can see the sound vibrations are causing it to thicken and harden up. And that's what gives it that really cool effect that's going on. The other two videos I will have in Canvas. And you guys can't hear that, but I can. The other two videos I will have in Canvas, and what they're going to be is, one of them is going to be the example of a Bingham plastic fluid. And actually, that's in context of a commercial from the 80s that I remember as a kid with ketchup, and it's just kind of silly. Let me go back there. And then the other one is a little short video from Brainiac where they're dealing with a shear thickening fluid, and it kind of gives you a preview of what we're going to be doing next week because it also talks a little bit about surface tension. So please watch those two videos right after this one.